This is on curve fitting. Scatter plots are helpful for understanding the form, direction, strength of a relationship between two variables. Correlation is the strength and the direction of a linear relationship between two variables. On this slide, there are three different graphs. The closer together data points are, shows a positive correlation. Notice the middle graph shows the data points a little bit farther apart. The data points are trending down, so they're going to have that negative slope. And then that graph to the right, the data points are farther apart. They're not showing that linear trend, so we say there is no correlation. If there is a strong linear relationship between the two variables, what we do is we can create a line of best fit, or a line that fits the data points, and we can make predictions. So in the future, we'll be able to create what we call a line of best fit, somewhere that looks something like that. So there are some properties of correlation coefficient. I'm just going to increase this a little bit so you can see the numbers. So our range of values for correlation coefficient are numbers between -1 and 1. The closer you are to -1 and 1, the stronger the data points are to creating that line. The farther out those data points are, the closer they are to 0. So if we look here at a correlation of 0, notice how far out these data points all are. When we have a data point of -0.95, the trend is there's negative slope. The points are pretty close together. A positive correlation, pretty close to 1, nice and close, positive slope. Now notice here, this is a -0.6 and a positive 0.6, so the points are farther away from each other. So what we'll be doing today is using technology to find those correlation coefficient numbers. And when we use our technology, we'll be using a graphing calculator. We do need to turn our diagnostic on. And how we do that, and it's going to look like this in the screen, is we have to turn within our graphing calculator in the catalog, second 0, and then choose diagnostic on. And we only have to do this once if we're using that same calculator. If we borrow someone else's calculator, you might have to do this again, but just one time, and that's going to be able to get you that correlation coefficient R. Okay, so here's an example one. It says Akron, Ohio and Wellington, New Zealand are about the same distance from the equator. Make a scatter plot for the temperature data. Identify the correlation and then sketch a line of best fit. So we have the months January to December for the average high temperatures for those two cities. And then you see those data points graphed out. So we have a trend of the data points decreasing. So you're seeing in January through December. And so what we do is we take our data points, and we have this as our list 1. And this will be our list 2 with the graphing calculator. And I'll show you this in class. We will type them in. So we first plot the points using technology. So think of this as like your x-axis. So this will be your list 1 points. And this is your y-axis. And this will be your list 2 points. And then what you do is you would identify the correlation and then create your line of best fit. And what you get is an equation that looks like this, a linear equation. This is the line of best fit. And it will be in slope-intercept form, y equals mx plus b. And what you can do is you can make predictions within that data set, make predictions. So let's say you want to find out what would be the temperature right within here, those months. You could use that data table there, or you could use your line of best fit. All right, here's example number 2. So this is kind of running through with the graphing calculator. Anthropologists use known relationships between the height and length of a woman's humerus bone and the bone between the elbow and the shoulder to estimate a woman's height. So there are some samples shown in the table. So the bone length and the height of a woman. So when we type this into the graphing calculator, this would be list 1 in the graphing calculator, and then this would be list 2. So what you would do is you'd first make a scatter plot. So here is the scatter plot graph. And then what you would do is you would enter those data points into the graphing calculator, and I did put those steps for you here, and we will do this together in class also. And this is what the viewing window will look like when we're done, and it gives you the y equals ax plus b. The a represents the slope, and the b represents the y-intercept. And then what we want is the correlation coefficient, the r, not the r squared. And then what we can do is we can make predictions. So we have an equation. So here's our equation right here. And let's say a humerus of 32 centimeters was found. What we can do is we can predict a woman's height. So what you would do is you would substitute 32 in for the length, and you can find the height. So we will run through this example together in class too.